Okay, this is Limits Day 2 notes. And the first thing it says is that you can use your calculator, but I want to remind you that you do not have to use a calculator in this first part. So what I would do is plug in a -1 into your x value to see what you get. And when you plug in a -1, you get a 1 minus 3 plus 2 over 1 minus 4 plus 3, and that gives you a 0 over 0. And remember, when you get a 0 over 0, that means that you can factor this. So I'm going to say the limit as x approaches -1. That's going to give you an x plus 2 over an x plus 1. And then on the bottom, you're going to get an x plus 3 times an x plus 1. The x plus 1's cancel. That's where you're going to have a hole at -1. Now you're going to plug in your -1, and that gives you a 1 over 2. Okay, I'm going to go down here to number 3 and do the same thing. Plug in a 3, so that would be 3 minus 3. Gives you 9 minus 9, and it looks like you end up with a 0 over 0 again. So factoring the limit as, whoops, those variables should be the same. So I'm going to say x approaches 3. So 3 minus x over x plus 3 and x minus 3. Okay, these look very similar, this top and this bottom. So what I'm going to do is factor out a -1, and this gives me a -3 plus x over an x plus 3 and an x minus 3. Now this parenthesis and this one are exactly the same. They're just written in opposite order, so these cancel out. That's what 0 over 0 tells me. So I have, whoops, I forgot to do something here. I should have the limit as x approaches 3 here. So I'm still working with this. Now, the limit as x approaches 3, I have -1 over x plus 3. And when you plug in your 3 now, I have -1 over 6. Okay, if I plug in a 0 so that I have sine of 0 over 5 times 0, well, sine of 0 is going to give me 0, and then I have a 0 on bottom, of course. So, of course, I have something that I need to work with. If you would like to plug this into your calculator, you need to be in radian mode since we're doing sine of x, okay? And I would take a minute to do so. I'm not going to show you here. So sine of x over 5 times x. Look in your table for this. And look at x approaches 0. And you should see in your y column that x is approaching 1/5. Or it's probably in decimal mode, which is 0.2. And a 0 here. This is 1 minus cosine of 0 over 0. Of course, you have a 0 on bottom. And then cosine of 0 is 1, and 1 minus 1, that gives you 0 on top again. In your calculator, plugging this in into your y, and look at x equals 0, and your function is approaching 0 this time. Okay, some properties of limits that we need to know. It says let b and c be real numbers, let n be a positive integer, and f and g are functions. These are our functions with the following limits. Okay, so as x approaches c, your f of x equals L, and as your limit of x equals c, approaches c, your g function approaches k. So this is important right here. So I'm going to come back to that. On number 1, it says a scalar multiple. Well, what a scalar multiple is when you have an expression multiplied by a real number. And I'm going to show you what that is. So I'm going to rewrite this right here. I have b, and then I have a function. So I'm going to rewrite the limit as x approaches c of your function x, and I have b. Well, b is going to be multiplied by this limit. So here is my expression, or my function, which is multiplied by my real number b. So that's what scalar multiple means. Okay, so I would rewrite this, and I could say that my limit of f of x right here is the same thing as L. So I would rewrite this as b times L. Sum or difference, I can rewrite this right here as the limit as x approaches c of f of x, and I can say plus or minus just like it says, my limit as x approaches c of g of x, and that is the same thing as f of x is L plus or minus k. And I'm getting this all from this box up here. Product. So I can take my limit as x approaches c of f of x, and I can multiply that by the limit as x approaches c of g of x, and that is the same thing as saying this function, which is L, multiplied by this function, which is k. And you could just say that's LK. Same thing. All right, let's divide. So I've got the limit as x approaches c of your function f of x divided by the limit x approaches c of g of x. So f of x is the same thing as L, and g of x is the same thing as k. So that's L divided by k. And a power rule means that you have an exponent. So I'm going to say the limit as x approaches c of f of x. And I can't really write this any different. This is still raised to the nth power. But I can say this inside here is the same thing as saying L, and now this is raised to a power. Okay, so now that you know some properties, let's use those properties. Okay, so here I have, this is your given, like we had before. So the f of function is equal to 9, and your g function is equal to -2. So I can rewrite this and say this is your b, so this is your whole number, this is a scalar, and the limit as x approaches c of your f function. So this is like saying 4 times 9, which is 36. Okay, here your f function, so the limit as x approaches c of f of x plus the limit of x approaches c of g of x. So your f is going to be 9 plus your g, which is -2, so this would be 7. And the last one here, this is your exponent or your power rule. So the limit as x approaches c of f of x raised to the -3/2. So f of x is 9, and I'm going to raise it to 3/2. You could rewrite this as 1 over 9 to the 3/2, which is 1 over 27. Let's move on. This one says find each limit algebraically. So the first thing that I would do no matter what is to plug in what they're asking your limit to approach. So this would be 1 over 5 plus 0 minus 1 over 5, and that's over 0. So this is going to be 0 over 0. That means that you can factor. Okay, this is all about showing your limits and showing your process. So I'm going to say the limit as x approaches 0, and I'm going to start finding a common denominator. So what I would do is 1 over 5 plus x minus 1 over 5, and that's over x, and I'm going to multiply by a common denominator on both the top and the bottom, and that's going to be 5 times 5 plus x, and this is going to be 5 times 5 plus x. I put an extra parentheses there for some odd reason. Okay, so when you find your common denominator, you're going to multiply the top and the bottom. So let's keep working with that. Every time I rewrite this, since I haven't plugged anything in, I'm going to rewrite my limit. When I multiply this first parenthesis times my common denominator, I'm left with a 5. When I multiply this by my common denominator, I'm left with a 5 plus x. And I left it in parentheses because I have a minus. On the bottom, when I multiply times my common denominator, it might be easiest to go ahead and multiply this out, but I didn't. So I'm left with a 5x. And then the parenthesis of 5 plus x. Okay, still keeping my limit as x approaches 0. On the top, I'm just going to distribute. This is 5 minus x. And on the bottom, I'm just keeping this as is, and you're going to find out why in just a minute. Okay, simplify what you can. So the 5 minus 5 is gone, and then my x I can simplify. So I have the limit as x approaches 0. I end up with a -1 on top. I have this x is gone. I have a 5 on bottom, and I have a 5 plus x. Okay, so I've simplified all I can. So I'm going to keep going. I'm not writing my limit because I have no more simplifying. I'm now going to just plug in my 0. So I have a -1 over 5 and 5 plus 0. So I'm plugging in my 0 now. And that should give me a -1 over 25. And that's what I am approaching. My function is approaching -1 over 25. Okay, number 7. Go ahead and plug it in to see what you get. So this is the square root of 0 plus 1, and that's -1 over 0. So that would be 0 over 0. So that's discontinuous. So now let's see what happens when we start simplifying. So I have the square root of x plus 1 minus 1 over x. Okay, to simplify this one, what I would do is multiply by the conjugate. This conjugate is going to be the easiest, it's the top, and I know it looks the hardest, but it would be x plus 1, and this is going to be plus 1. That's what makes it at the conjugate. Okay, so still having limit as x approaches 0. I'm going to double distribute. So here's your first term of each one. So x plus 1 times x plus 1 gets rid of your square root. So that would be x plus 1 plus the square root of x plus 1. That's going to be minus the square root of x plus 1. And that's going to be minus 1. So I just double distribute. On the bottom, I'm just going to combine everything. It looks like I have x times the square root of x plus 1 and then plus 1. Okay, I'm going to start simplifying. It looks like this is gone, your square roots. My 1 is also gone. And it looks like my x on the top and the bottom is gone. So I have the limit as x approaches 0. I have nothing on top, so I'm going to do a 1 as a placeholder. On the bottom, I'm left with x, the square root of x plus 1, plus 1. So now I'm ready just to plug in my 0. So I have 1 over the square root of 0 plus 1, and then plus 1. So it simplifies down to 1/2. So as x approaches 0, my function is approaching 1/2. And number 8, if we were to substitute in a 1, that gives me 2 times x plus 1 minus 5x over 1. That gives me a 2x plus 2 minus 5x. And that's a what? 2 minus 3x. Okay, let me give you a what if. What if you had a limit of y approaching 0 of this same problem? That means that I would have 2 times x, let me just rewrite this, of my same problem. That means that I would have the limit as y approaches 0. This gives me 2x plus 2y minus 2x over y. And I'm doing this because it looks like my x's are canceling out. I end up with 2y over y. And if I plug in my 0 here, right here, then I end up with 2. So it just kind of gives you an idea of just the difference as you're approaching 1 or if you're approaching 0.